Going on, guys? In this video we are going to see how to find out the Laplace transform of e power at. Laplace transform of e power at, and that can be found out using this integral. This is a generic integral, 0 to infinity e power negative st, and whatever the Laplace transform we are trying to find is the one multiplies. So e power at dt. Now this one 0 to infinity e power, here if we take t common, this is going to be just a minus s, because when we multiply the powers will add. So a minus s times t dt. Now what we are going to do is we are going to take this infinity and say limit n approaches infinity, because when we have indefinite integral we can use that. So limit n approaches infinity, so this is going to be 0 to n. We replace this infinity with n and then e power a minus st dt. Now let's go ahead and do the integration. If we do the integration, this is going to be limit n approaches infinity. If we do the integration for this one, this will become 1 over a minus s e power a minus s t. We still have to apply the limit, that is 0 to n. Okay, here we know that n approaches infinity. So if n approaches infinity, then we have to apply n approaches infinity and also n approaches 0. To do that, let's go ahead and do that. Limit n approaches infinity, and all the t terms will be the thing that will be replaced with n and 0. So 1 over a minus s e power a minus s, the first limit n right here, then minus, I put the other one, that is 0. 1 over a minus s e power a minus s times 0. Let's go ahead and continue here. Let's go ahead and continue here. Here we want this one to be 0. To get the 0, we have to have a negative number here, because when we multiply n by a negative number, that will be a huge number in the denominator, because e power negative infinity is 1 over e power infinity, so it's a huge number, so we will get 0. So in order to get 0, we had to have a minus s should be less than 0, and we want 0 here. Want is 0. So to get the 0, this is a condition, and if we get that thing, get a negative number, the first value is going to be 0, then minus. Since I applied the infinity, I don't have to put that on anymore. And here we have 0. If you put 0, this e power 0, that's just 1. So we will still end up with 1 minus and 1 over a minus s. Okay, because e power a minus s times 0, this is going to be 0. E power 0 is 1, so this is going to be just 1 over a minus s. 1 over a minus s mean 1 over s minus a. If a minus s is less than 0, negative s is less than negative a, therefore s should be greater than a. So 1 over s minus a. That's the this is our final Laplace transform of e power at, and that's how we do that. I hope you guys find this video helpful. Thanks for watching, and don't forget to subscribe. See you next time.